So let's start. 2, 8, 18, 32, 50. Well, if you take the first difference, this is 6, this is 10, this is 14, and this is 18. Take the second difference, right? Now it tells us that it's not linear, so if you take the second difference, it's 6 to 10 is 4, 4, and 4. So we're going to have that, right? We're going to have 4. And that is going to be our coefficient in front of n squared. And we put a 2 in here. Now, you might as well just memorize it. I mean, there's nothing to memorize, but everything's going to be based on an n squared, right? When we find a coefficient. So n squared, I mean, think about what an n squared sequence looks like. It's 1 squared, 2 squared, 3 squared. So it'd be 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squares, etc. Right? Now, a 2 times n squared would be that particular sequence, but just double it, right? So 1 squared is 1, times 2 is 2, 2 squared is 4, times 2 is 8, 3 squared is 9, times 2 is, 3 squared is 9, times 2 is 18, 4 squared is 16. Well, notice that it looks like this, like the original sequence that we had, right? So 25 squared, 5 squared is 25 times 2. Now, we are, and I'll highlight this, we have to take the original sequence, let me make my highlight a little bigger, and the sequence that we just got, and we're to subtract both of them. In this case, 2 minus 2 is 0, 0, 0, 0, and 0. So that tells us that there is no other sequence in here. That is just, there's no other parts to the sequence. So our nth term is 2n squared. And that will work. And again, if you say n equals 5, what is our fifth term in our sequence? Do you get 50? Yeah, you do. If you plug in n equals 4, if you get 6, you get 32. Yes, you do, etc. etc. So I can ask you for the 88th term. Well, you would plug 88 here, take it to the second power, and multiply by 2, and you would be able to tell me what the 88th term is. So this is what we need. Okay, so that was simple. Yep, I'm not feeling too well. Alright, let's take a look at the next one. Right, so I mean, it gets repetitive after a while, but let's hopefully do a few that will take us a little bit further. So first difference is 6. This looks like 10, this looks like 14, and this looks like 18. So it's 4 again, 4 and 4, right? 10 minus 6 is 4, 14 minus 10 is 4, 18 minus 4 is 4. Okay, so I'm going to have 4, right? Which is going to get us this again. And we just did it. So let's see, it was 2, it was 8, it was 18, it was 32, and it was 50. So again, look for us, same numbers. We're going to subtract, and we get 1, 1, 1, 1, and 1, right? Again, I am subtracting this minus this. So I'm going to take the 2n squared sequence out of the original, and I'm left with 1, 1, 1, 1, and 1. So when all the numbers are the same, well, if I were to take the first difference again, there is no sequence here. 1 to 1 is plus 0, plus 0, plus 0, plus 0. So there is no another sequence inside this line here. So we're not going to do this. Basically what this is telling you is that 3, 9, 19, 33, 51 is a sequence that is a 2n squared sequence. But what do we have to do to a 2n squared sequence to get 3, 9, 19, 33, 51? We have to add plus 1. So again, that's our nth terms, and that's just confirmed. So if I asked you for the fifth term, you would go 2 times 5 to the second power, right? I'm replacing the m as 5. and then plus 1. Well, 2, 5 to the second power is 25, and then plus 1, look at that. That gives me 51, which is the 5th term. Try the 3rd term. We should get 19, so if we use this expression, 2n squared plus 1, and we plug in the 3, we get 2 times 3 squared plus 1. 3 squared is 9, times 2 is 18, plus 1, look at that. We get 19. So this expression here, right, helps me find whatever term I need. So again, if I want to find, like I said before, the 88th term, plug it in here, right, and you would get the 88th term right here. Okay. All right. Let's see. Let's move on a little faster. 4, 11, 22, 37, 56. Well, that is what is that? 7, 11, 15, 19. Second difference is going to be 4, 4, 4. So again, over here, we found the coefficient, so take 4, half 4. I take that, divide 4 by 2, and we get 2. A 2n squared sequence, again, let me write these numbers here. And we get 2, 8, 18, 32, 25. Sorry, 50. Right? It's 2 times 1 squared, 2 times 2 squared, 2 times 3 squared, 2 times 4 squared, 2 times 5 squared. That's how I got this line. Now let's subtract. Right? This is my original sequence, and from that I'm going to remove this. I'm going to remove the 2n squared sequence from there, and I'm going to be left with hopefully something else. So in this case, 4 minus 2 is 2, 11 minus 8 is 3, this is 4, 37 minus 32 is 5, and 56 minus 50 is 5. Sorry, oops, 6. All right, now I have a sequence. So there is another sequence inside here. So inside our original set of numbers that were given to us, we know that there is a quadratic sequence, and that's the part of it. Now there's something else in there. There's this sequence here. So I need to start all over, right? 2, 3, 4, that's a sequence, right? So it's a linear sequence. Well, 2 to 3 is 1 plus 1, 3 to 4 is plus 1, 4 to 5 is 1, 5 to 6 is 1. So it's a linear sequence, and a linear sequence starts with something ends, something n, right? And in this case, it's 1n. So this is our coefficient. And I'm going to put the 1 over here, even though you don't need it, right? And I'm going to find the first 5 terms of a 1n sequence. Now, I'm going to take the 1, plug it in here, take the 2, plug it in. So 1 times 1 is 1, 1 times 2 is 2, 3, 4, 5. It's just a 1n sequence. Subtract. 2 minus 1 is 1, 3 minus 2 is 1, 4 minus 3 is 1, 5 minus 4 is 1, 6 minus 5 is 1. So 2, 3, 4, 5, 6 is an n sequence, but I need to, and to make it easier, add 1 to it. And that's what I got. So our sequence made up of this, and this. Now, 1n, think about 1n. So if I gave you the nth term, in this case, it's n, and I said, hey, what is the first sequence, first term in a sequence that's just n? Well, you would just plug in 1 in here, and the first sequence, the first number of the sequence would be 1. What is the 256th term in this sequence, this being my nth term? Well, it'd just be 256. There's nothing else to do in there, right? We just substitute there. So the second number in the sequence would be 2, the second number in the sequence would be 3, and 4, and so forth. That's how I got the 7. Right? So now this this sequence right here, and I won't highlight it, but this sequence right here is an n sequence, right? It's a 1n sequence, but with a little bit of an adjustment. It's an n sequence, but I need to add 1 to it. And that's how I get this. So now if you took that, and let's plug in 5 again here, right? What is the fifth terms of this? So if I gave you this, what is the fifth term? Well, you will do 2 times 5 squared plus 5 plus 1, right? I want the fifth term. So 5 squared is 25. 25 times 2 is 50. Plus 5 plus 1. That gives me 56. Look, I get this. All right, so basically, we're doing the, I guess, the numerical side of it, finding sequences instead of we doing it visually, like when we do the visual patterns. So this is just the other side. Okay. Right. Let's push a little harder. 5, 13, 25. Make it a little faster. First difference is, looks like 8, 12. Is it 12? Yeah. 16. This is 20. So it's not linear, right? So my second difference is going to be 4, 4. Oh, sorry about that. So I know it's quadratic, so this, right? This expression here it's made up of a quadratic sequence, and we're going to have 4, so we get 2. We should just memorize those numbers, right? So 2 times 1 squared is 2. 2 times 4 squared is, all you got to do is double that. So 8, 18, 32. So we're going to subtract. 5 minus 2 is 3. That's a 5. That's a 7. That's a 9. And that's a 11. So we start all over. Alright, so, sorry. Part of my answer. So here's my answer. Now it's going to be, now think about this. So if I gave you 3, 5, 7, 9, let me just even do this. Hope it works. Right, and I said, hey, and I said, so imagine I gave you this, right, and I asked you for, hey, what is the nth term in this sequence? Well, how are these numbers going? It's going to plus 2, plus 2, plus 2. Right, basically it's going up by 2. And what goes up by 2? Well, just sorry, plus 2, plus 2, plus 2, plus 2. So this is a 2n sequence, right? So we're going to take that 2 and put it here. What does a 2n sequence look like? Think of your 2 times table. This 3, 5, 7, 9, 11, it's your 2 times table, right? 2, 4, 6, 8, 10. But if you think about it, it's your 2 times table with a little adjustment. What's the difference between the numbers going 2, 4, 6, 8, 10, 12, 14, and then 3, 5, 7, 9, 11? Well, these numbers in red here have a plus 1. So, that. And the other way of finding that is to just subtract. 3 minus 2 is 1, 5 minus 4 is 1, 1, 1. So 3, 5, 7, 9, 11 is a sequence that can be described as a 2n sequence, but with a little tiny adjustment that we also have to adjust it by adding 1 to get that. So again, remember when we did something like this, 1, 2, 3, and this is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 2, 3, 4, 5, 6, 7, 8, 9, right, visually, and I asked you, hey, what are the, what is the next term, or what is the 88th term in here? Well, you would say, well, this was 3, this was 5, this was 7, and this was 9, and we did it visually. Well, again, this is the same thing. Okay. All right, so 1, 6. All right, so notice again, pretty easy, right? 0.4, 35. This is, okay, let's figure out. If you take the first difference and it's, let's say it was all 4, 4, 4, 4, then this would be a linear sequence. right? But I don't think it is. This is 5, this is 7, this is 9, this is 11. So it tells me that our answer here, our nth term, it's something n squared. We need that. So let's figure that out. Well, if you take the second difference, it's 2, 2, 2, etc. So n squared, and what do we put here? We take the 2, we divide it by 1, and then we put 1. But this, it's so there's a quadratic sequence inside our original. So 1 squared is 1, 4, 9, 16, 25, right? So 3 minus 1 is 2, 4, 6, 8, 10. So 1n squared. You don't have to write the n, but I'm doing it. Now we're going to find out if there's another sequence in there. And there is. Look, 2, 4, 6, 8, 10. It's you're 2 times it. It's a 2n sequence, right? Something multiplied by 2. So if I wanted the 5th term, I would just multiply by 5. I wanted the 100th term. So if I asked you, what is the 100th term in this sequence? Well, the first sequence is 2. The second sequence is 4. So third sequence is 6. So notice that I'm multiplying the term by 2, and I get the number. So the 100 sequence would be just 2 times 100, which would be 200. So this is, and again, plus 2, plus 2, plus 2, plus 2. So that tells you that our coefficient is 2. Right, and our slope, if we think about it, that's exactly what we just did. Our slope is 2. So now, plug in the numbers 1 through 5, and the first 5 terms of 2n sequence is 2, 4, 6, 8, 10. Subtract to get 0. So I don't need to make any adjustments to 2, 4, 6, 8, 10 to get this, right? It's not a plus 1 or plus 2. Look, because it was a plus 1 or plus 2 or minus something, then this would not be 0. So there's your answer. N squared plus 2n. You can always double check by plugging in, right? Plug in the number 5, plug in 5 in here. Find the 5th term. See if you get 35. Plug in 4. See if you get 24, and etc. Three, 8. Is that what I just did right now? 5, 16, 33, 56, 85. First difference. Let's see, 5 to 16 is 11. This looks like 17. Yeah. 23. 29. Right? Is that right? Yeah. Well, the second difference is going to be 6. This is going to be 6. And this is going to be 6. So put this little box here. So n squared. There's a quadratic sequence. What's going to be our coefficient? I'm going to take 6. Right. So there's a quadratic sequence in there. And what's our coefficient? It's going to be 3. Right. Because we take the 6. We have 3. Sorry, half 6. Half 6. We got 3. Right. So what does a 3n squared sequence look like? Well, take the n squared sequence and multiply it by 3. So 1 times 3 is 3. 4 times 3 is 12. 9 times 3 is 27. 16 times 3 is 48. And 25 times 3 is 75. Right, so let's subtract. Right, so we're going to subtract. Now highlight this. Subtract this line, our original sequence, minus the quadratic part that we just found. 5 minus 3 is 2. 4, 6, 8, and 10. So there's another sequence inside our original sequence, right? So we took the quadratic part out of it, and then let's focus on this on the bottom. 2, 4, 6, 8, 10. You can obviously see it's a sequence, right? It's not quadratic, it's linear, so it's going plus something plus 2 plus 2 plus 2 plus 2 plus 2, the same number over and over again, right? So let's go through the process. Plus 2 plus 2 plus 2 plus 2, which tells us that it's linear, and our coefficient in front of n is going to be the exact same number, that 2 there. So 2 times 1, think of it, the 2 times table, 2 times 1 times 2. So the first numbers, 2, 4, 6, 8, 10. And look, we don't have to make any adjustments to 2n to get to this line, right? It's actually the same. So if you subtract, you get 0. So this is just 3n squared plus 2. 0, 11, 28, 51, and 80. This is 10. I think the first, this is 10. This is 17. Sorry, what the heck? 11, 17, 23, 29. Good. Obviously non-linear. Take a second. 11, 17 is 6. This is 6. This is 6. So we're going to have 6, and our coefficient is going to be 3 and squared, right? Because we take the 6 and we divide it by 2, or have it 1, 4, 9, 16, 25. We're going to take these numbers and multiply by 3, so we get 3, 12, 27, 48, 75. So now we, okay, so let me put it in the box. We know the quadratic part of our sequence is 3n squared. Let's subtract. We get negative 3, negative 1, 1, 3, and 5. Careful when subtracting. So notice that there is a sequence here. Right, so let's take the first difference. This is plus 2. Negative 1 to 1 is 2. 1 to 3 is 2. 3 to 5 is 2. So inside here, it's linear. Right? So it's 2n, right? Because we just found that out. The 2n sequence. And think of it as a 2 times table. 2 times 1 is 2, 4, 6, 8, 10. But it's not 2, 4, 6, 8, 10. It's actually negative 3, negative 1, 1, 3, and 5. So what adjustment do I make to 2, 4, 6, 8, 10 to actually get negative 3, negative 1, 1, 3, and 5? So it's right here. So our answer is this with this. And our adjustment, well, all you got to do is subtract. You got negative 3 minus 2 is negative 5. Negative 1 minus 4 is negative 5. 1 minus 6. So, right? And that makes sense because it's a 2n sequence. So how do I get from 10 to 5? I subtract 5. How do I get from 8 to 3? I subtract 5. Right? This is a 2n sequence, but with a little adjustment of subtracting 5. I am going to eat and do this. Hopefully my headache will be gone. Alright, so negative 4, 3, 16, 35, and 60. This is negative 4 to 3 is 7, 3 to 6 is 13. This looks like 19, and this looks like 25. Yeah. Second difference, 7 to 13 is 4, 13 to 19 is 4. This is, no. And 6, 6, and 6. So n squared, our coefficient is going to be 3. Write these numbers down. So it's going to be 3, 12, 27, 48, 75. Right? So our expression already starts with 3n squared. But now we got to subtract. So be careful with subtracting because this says negative 4. And I'll put this in parentheses maybe. Negative 4 minus 3 is negative 7. 3 minus 12 is negative 16 minus 17 is negative 11. This is negative 13. That's negative 15. Okay. So now we do the first thing. Same thing. Sorry. Take the first difference. Negative 7 to negative 9 is negative 2. Right? So negative 7 minus 2, you get negative 9. Negative 9 minus 2, you get negative 11, and so forth. So over here, we're trying to find out what is the coefficient of the linear sequence. So this is going to be negative 2. Right? So it's your 2 times table, but with a negative side. So what does a negative 2 sequence, 2n sequence look like? Well, it's your 2 times table, but negative. Negative 2, negative 4, negative 6, negative 8, negative 10, right? Times 2, times 1, times 2, times 3, plus negative. Now we subtract. Well, because I don't want negative 2 or negative 4, negative 6, negative 8. I actually want negative 7, negative 9, negative 11, negative 13, negative 15. So I have to make a little adjustment to this sequence right here. Right? It's a negative 2n sequence plus or minus something. Well, how do I get from negative 2 to negative 7? Well, it's going to be minus 5. So negative 2 minus, I got negative 7 minus negative 2 is, yeah, so we're going to subtract, and then negative 7 minus 2 is negative 7 plus 2, which gives you negative 5. This is also going to be negative 5. So think about it. Negative 9 minus negative 4 equals the same thing as negative 9 plus 4, which equals negative 5. And the same thing repeats over and over. So, to the negative 2, negative 4, negative 6, negative 8, negative 2, I have to add negative 5 to get to that. So, that's my answer. Alright. So, first difference we got 1, 3, 5, 7. Second difference we got 2, 2. So we're going to have 2. So the coefficient for in front of my n squared is just going to be 1. Oh, that's a nice part. Right. 1. So it's just 1, 4, 9, 6, 5. Let's subtract. Negative 6 minus 1 is negative 7. Negative 5 minus 4 is negative 9. Negative 2 minus 9 is negative 11. Obviously negative 3 minus is negative 13. And then 10 minus 25 is negative 13. So we found our quadratic part of our expression, which is just n squared. The first difference again. This is negative 7 to negative 9 is minus 2, minus 2. So it's a repeat of the previous one. So we have a 2 times table sequence, right? They are two times table sequence, but negative. So it's negative 2 times negative 2 times 1 is negative 2, negative 2 times 2 is negative 4, and then times 3 times 4 times 5. So we're going to subtract, but another way of thinking is to this sequence of negative 2, negative 4, negative 6, negative 8, negative 10, what do I do to get to negative 7? Well, you could just kind of say that you can subtract minus 5. So we get negative 2, and did I just do this wrong? Negative 5, minus 5, minus 5, minus 5, minus 5. Negative 7 minus, I put this in parentheses, minus negative 2 is minus 5. Negative 1, 0, 3, 8, 15. this is 1, this is 3, this is 5, and this is 7. So the second difference would be 1, 2, 3 is 2, plus 2, and then plus 2. Okay. So we have a quadratic. So here's my nth chart. So we have a quadratic sequence in here, and the coefficient is, well, 2 divided by 1, so it's just 1. What does that look like? It's just 1, 4, 9, 16, 25, etc. Subtract the original minus this one, so negative 1 minus 1 is negative 2, 0 minus 4 is negative 4, 3 minus 9 is negative 6, 8 minus 16 is negative 8, 15 minus 25 is negative 5. So notice that this is a linear sequence, right? It's going to be minus 2, minus 2, minus 2. So if we take the first difference, notice from negative 2 to negative 4, minus 2, minus 2, minus 2, minus 2, right? Well, that tells us that our coefficient in front of n, so we have a coefficient, so we have the linear part, right? And the coefficient here is going to be minus 2. So negative minus 2 and minus 2 and sequence goes, well, substitute 1, 2, 3, 4, 5. You actually get the same numbers, right? I don't have to make any adjustments. But if you subtract this, you get negative 2 minus 2, which is negative 2 plus 2, and you get zeros. So that is our final answer. And like I said, you can always double check. Plug in 5, plug in 4, plug in 3, and you should get 15, 8, 3, 0, negative 1. We have 2, 4, 6, 8. Second difference is just 2, 2, 2. So our quadratic part of it, take 2, divide that by half that, and we get 1. So inside our original sequence, there is an n square sequence, which is 1, 4, 9, 16, 25, etc. We're going to subtract our original minus the one we just put in. 0 minus 1 is negative 1, 2 minus 4 is negative 2, 6 minus 9 is negative 3, negative 4, negative 5. So notice that there's another sequence inside, so we got to repeat the process. Take the first difference from negative 1 to negative 2. What do we do to get from negative 1 to negative 2? That's what you so you have to subtract 1, and there's subtract 1, subtract 1, subtract 1, right? So our linear part of this our sequence is a negative 1 n sequence. So let's find out what the first 5 terms are. Well, over here, plug in 1, 2, 3, 4, 5, and see what you get. Well, if you plug in 1, you get negative 1. Plug in 2, you get negative 2, 3, 4, 5, which is exactly what's left over when you subtract it. So negative 1 minus 1 is just 0, so this is all 0. So I have to make no adjustments to this line to get to that one. So it's just n squared minus n. So it's pretty simple. What's that, 12? This one. Right. Right, half of 1, right, is 0.5. So 1, 4, 9, 16, 25. So this one has decimals. The quadratic part is 0.5. Right, so half, that's fine too. N squared, whatever you want. I should have written half, but it's okay. Well, it's this sequence here, right? Half 0.5 or n squared sequence of this sequence. So we're actually going to get 0.5. Second term is going to be 2. second term is going to be 4.5. It's going to be 8. And 0.5, 2, 4.5, 8. And the last one is 12.5. I'm doing something wrong. Alright, so let's see. Negative 0.5. This is minus 1, minus 1.5, minus 2, and then minus 2.5. 0 minus 0.5 is negative 0.5. 1 minus 2 is negative 1. 3 minus 4.5. So remember, we're subtracting, right? So there is a sequence, so we gotta continue. Take the first difference. Negative 0.5 to get to negative 1 is minus 0.5. And again, minus 0.5, negative 0.5, and negative 0.5, right? So our linear part of this, the coefficient is going to be negative 0.5, or half of n. So if you multiply the numbers 1, 2, 3, 4, 5, because those you plug it in here and then multiply it by half, you're actually going to get 0.5, what's half of 2, right? Half of 3, half of 4, half of 5, and so on and so on. So if you subtract these two lines, right, negative 0.5 n, you actually get 0. You have to make no adjustments to the negative 0.5 n. Okay? Okay. So this is plus 10, plus 20, plus 30, plus 40, obviously not linear, so the second difference is 5, not 5, sorry, plus 10, plus 10, plus 10, half of 10, 5, so that's going to be, here's my n term, for the quadratic part, n squared, what's my coefficient is going to be 5, so 5n squared, so this is your n squared, multiply that by 5, so you get 5, 20, 45, 5 times 10 is 50, and 5 times 125 is 125? 5, 10, 45. Oh, it's 16, sorry. 16 times 5, which is 80. And then 5 times 125. So we're going to subtract now. 0 minus 5 is negative 5. 10 minus 1 is negative 10. 15, 20, negative 20. So obviously a sequence there. So we got to find the coefficient from the end. So this, as you can obviously tell, it's your 5 times table. It's a 5n sequence by negative, right? So this is minus 5, minus 5, minus 5, minus 5, right? So from negative 5 to go to negative 10, you subtract 5. From negative 10 to go to negative 10, you subtract 5. So that ends up being my coefficient here. What does a 5n sequence look like? It looks like exactly what we have here. It's negative 5, right? Negative 5 times 1, negative 5, negative 5 times 2, times 3, times 4, times 5. So I need to make no arrangements to this sequence to get to this sequence. Right? Because it's all going to be 0. Right? So it's so that's that. 15. 2 more guys. No, not even going to. It's chicken soup. First, it's what is this? Plus 9. 19. 28. Alright. That's the plus 9. The next one is no, it is 19. Then 56 minus 27 is 29. And this should be 39. Yeah, plus 10, plus 10, plus 10. So the second difference would be 10, 10, and 10. And let me just start. The quadratic part of our nth term is, we're going to have 10. Right? Half 10 is 5, so it's going to be 5n. So we're already know part of our answer. What does a 5n sequence, 5n square sequence is? 5n square sequence looks like, well, it's this sequence that I'm writing right now times 5. So 5 times 1 is 5, 5 times 4 is 20, 5 times 9 is 45, 5 times 16 is 80, and 125 is 65. So let's subtract. Negative 1 minus 5 is negative 6, 8 minus 20 is negative 12, 27 minus 45 looks like negative 18, 56 minus 80, is it 24? Yeah, it is. And then negative 30. So, start the whole process again. First difference, how do I get from negative 6 to negative 12? Well, I subtract 6, subtract 6, subtract 6, subtract 6. So there is a sequence in here, right? In this, that's this is 6, 12, 18. It's your 6 times 2, but negative, right? So it's the coefficient in front of them. In this case, is going to be negative 6. There we go, minus 6. Do I have to make any adjustments to a negative 6n squared to get negative 6, 12, 18, 24? No, I don't. Because look, when I plug in 1 here, I get negative 6. When I plug in 2, I get negative 12, so forth, so forth, so forth. So they're all going to be 0, because negative 6 minus negative 6 is 0. Negative 12 minus negative 12 is 0. Right? 0, 0, 0. So there's my answer. And then we have one more. Negative 4, 5, 4, 23, 52, 91. So from here to here is 9. From 23 to 4 is 19. They're the same numbers here. And then from 52 to 23 is 29. And then 91 to 52 is 39. No, I don't think so. But, sorry, first, take the second difference. 19 minus 9 is 10, 29 minus 19 is 10, 39 minus 29 is 10. Okay, I don't know why I did that line. It's a quadratic, right? Sequence. And in there, we're going to have 10. Well, half of 10 is 5, so it's a 5n square sequence inside our original sequence of negative 5, 4, 23, 52, 91. So again, right, what an n squared. This is what an n squared sequence looks like. 16, 25. I'm going to multiply all that by 5. Right? So we get 5 times 1 is 5, 5 times 4 is 20, 5 times 9 is 45, 5 times 16 is 80, and 5 times 25 is 25. It's in parentheses here. Now we're going to subtract. So negative 5 minus 5 is negative 2. 4 minus 20. 4 minus 20 is negative 16. 23 minus 45 is 22. 4, yeah, negative 22. This is negative 28. And yeah, this is negative 34. So, take the first difference again. You can subtract negative 16 minus 10, or just think, how do I get from negative 10 to negative 16? Well, obviously subtract 6, subtract 6, subtract 6, subtract 6. So if you look at the sequence, 10, negative 10, negative 16, negative 22, negative 28, it goes by 6, right? 6 plus 6, minus 6 in this case, minus 6, minus 6, minus 6, minus 6. But, so it's the same. So let me write this right n here, and here's my coefficient. is the same thing that happens when you have a 6 and a 6n sequence. In this case, well, it's the first term in a negative 6n. Well, plug in 1, we get negative 6, negative 12, negative 18, negative 24, negative 30, right? So this line here and this line behave the same way. They both go on, but by add negative 6, add negative 6, add negative 6, except that to this line here, right? In order for this line to be the same as this line, I have to make a little adjustment. Because a negative 6n sequence is negative 6, negative 12, negative 18, negative 24, negative 30. So what adjustments do I make to this line to look like this line? Well, I don't want negative 6, actually. I want negative 12. So how do I get from negative 6 to negative 10? Sorry. I subtract 4. How do I go? Instead of negative 12, I want negative 16. How do I get to negative 16? I subtract 4. So if you think about that, you know that your answer is, it's a negative 6n sequence, but with a little adjustment of, I need to subtract 4. The other way of you doing this is subtracting, right? Negative 10 minus negative 6 is the same thing as negative 10 plus 6, which gives you negative 4. This also would give you negative 4. Okay, that was it.